This is a presentation by Christian Schmidt, Eric Mendoza, and Esmeralda Lopez, and this is biogas generators. This is our table of contents. What is a biogas generator and where can it be used? Biogas generators are systems that convert animal waste or specifically grown crops such as corn into energy. Biogas is used in appliances that use natural gases such as cooking, space and water heating, drying, and gas turbines. Biogas can be used for electricity production, commercial and residential buildings, and ground transportation in order to replace natural gases. This is a diagram of an ASIN generation system, and it shows the collection process. More on the collection process. On a farm with 200 cows, cow dung is collected and moved to the mixing chamber manually. Once in the mixing chamber, it is unloaded and is mixed with water, and substrate is mixed manually. Then unwanted elements are separated before being sent through the chamber, where organic matter is screened to remove further unwanted objects. Then, once the cow dung has been through both the mixing and inlet chamber, it is passed to the biodigester. The cow dung mixed with water flows from inlet chambers into a biodigester, where fermentation occurs. At this point, biogas is produced. The digester in this example is a floating dome type of digester. The top of the dome holds the biogas, while the bottom holds the cow dung mixture. The other side of the digester has a sludge chamber, which holds all liquid sludge after fermentation. Moisture accumulated from the biogas is removed with the help of moisture traps. Electricity generation.
Now that we've gone over the collection data, this is the information that we're able to gather from our biodigester generators. So we have the gas temperature, digester liquid temperature, gas press and headers 1 and 2, the ambient temperature, generated gas total, supply freshwater total, recycled water total, methane percentage, and the sulfonium reading. The ASIN generators, they're called Corimo. These are the information that we're able to gather, and this information is collected 24/7 to ensure their system is operating properly. So for Corimo 1, we have the generated power, DC voltage, grid's power supply. We have the engine revolutions, the throttle valves, the fuel valves, ignition advanced temperatures, engine coolant temperatures, and the radiant temperature. And Corimo 2, slightly different values, but same information. And the reason why we have two separate data tables for these two generators is because they're both used for separate parts of the farm. So, we can see right off the bat the generated power for Corimo 1 is slightly higher than Corimo 2. And again, that's just because of the location that they're based off of. And these Corimo generators are used on a Sri Bhaglakshmi farms. I'm sorry if I butchered that. It's located in southwest of Bangalore. It's a very rural part of the city, so this type of generator works perfectly for them because they need cow dung to produce energy. So they have, it's a dairy farm, so they have dairy equipment powered off this gas, their milking machines, the lighting for the entire farm, including for those who live on the farm, and they also use that gas for cooking or heating purposes. And the most important part of this is the control room. The control room would let the workers of the farm know if the system is not operating the way it needs to. So going back to these two, as I said before, the generated power, there is a difference. Let's say Corimo 2 one day was reading 700 to 800 watts produced. The control room would then let the workers know that something is wrong with that system. That way the workers can then go inspect and repair any type of deficiencies it may have. And a benefit of this type of system is that this one is used on a farm specific, so it's very self-sufficient. They only need cow dung to produce the biogas. The sludge output from that is then used to fertilize their crops, which, we have the crops growing, crops go to the cows, cows produce more dung, and the cycle will just continuously repeat. And compared to something like liquid nitrogen gas here in the States, where it has fracking, we have to dig up minerals, this type of system is 100% self-sufficient.
Now, there are many pros and cons that come with the technology of biogas and biogas generators. The pros are biogas is eco-friendly, as there's no combustion, it's zero emissions, and it only uses renewable materials. Biogas reduces water and air pollution. As it's zero emissions, there's no pollutants that are going in the air. Biogas generators make organic fertilizer, which can replace chemical fertilizers, which is a bonus in itself. It's simple and low cost. It pretty much pays for itself, as the materials used to generate power are free. And it's a healthy cooking alternative. It can be used for cooking instead of stuff like firewood, which produces smoke that's harmful for the environment. There's a few cons that come with it, though. It hasn't really advanced over the years because there's not a lot of interest in it, as the world's pretty much been run by fossil fuels since the industrial era. So there haven't been a lot of advancements in this green technology just because the world revolves around fossil fuels. There's some impurities in the refinement, so it's pretty corrosive. And another big one is that temperature affects biogas production. And there's an optimal temperature, which is around 37 degrees Celsius, meaning if you're in a colder climate, you'd have to heat the system in order to produce biogas. And it's not really suitable for densely populated areas, as the raw materials, being cow dung, are only in rural areas. So it's not really suitable for populated areas. There's many countries that use it. The leading countries are Germany, UK, the US, and China, as they collect biogas from landfills. And in total, only 1.5% of global renewable energy is produced by biogas. In Australia, the biogas industry is emerging, and in 2017, 242 biogas sites, half of them were landfills collecting landfill gas. There's a future for biogas, as this presentation kind of entailed. With over 3 million people in the US, fossil fuel industry is not sustainable forever. While we are not proposing an overnight change, we must start considering and adding our current green energy technologies. That way, when the time comes, it can be a seamless change. Biogas is one of these technologies. With massive amounts of landfills located throughout the world, biogas can produce energy from solid waste. While it has its issues, working with other green energies, it is possible that one day we could be fully operating on nothing but renewable energy source, which can reduce our carbon footprint. Here's our sources.